So I'm Kris Wallsmith, and I'm going to be talking about how I write Symfony apps. I think there's a lack of presentation of how individuals that you might know actually do the work that they do in the closed source world. When I'm hired to build an app, or if I'm building an app for myself, what the process is that I go through, how I organize my code, and so this presentation is meant to be nothing more than what it says it is. This is how I do it, and I'm up here to share it with you. And so I'm not telling you that you should do it this way. I'm telling you that this is working well for me. So any questions that you have, please ask. I can take questions whenever during the course of the talk. I've also shortened it somewhat because when I gave this talk last year in Warsaw, there were a lot of questions at the end. So I'm hoping that as I go through this, that you might have some questions, and that you'll speak up if you do. And maybe you'll even convince me that I should do it your way, which is fine. And maybe you can come up and give one of these talks that says how you do things. And I would actually love to see other people make apps, make presentations about how they make apps. So I've given this talk a few times, and the overall sense of what I'm trying to share is how I organize my code, determining what goes where, what to break apart, what goes in the controller, what I should create a service for. Should this be the same service or a new service? So one of the ways that I am able to figure out what goes where is by trying to identify what the mapping layers are. So before I get into what they are, what the exact mapping layers I find in my applications are, let's talk a little bit about what a mapping layer is. One of the defining characteristics in my mind is that it's thin. A mapping layer, for those who don't know what I'm talking about, is kind of mapping from one language into another language. I use the term language very loosely. So mapping from one way of doing things into another way of doing things, just a separator, a translator from one world into another world. So that mapping layer is very thin. Its only responsibility is translating from one way of doing things into another way of doing things. So if I say thin, you might think, for example, thin controller fat model. This is a term that's been bantered around quite a bit over the past couple of decades or a long time. So thin controller, fat model. This is the idea of having your controllers be very thin and then moving the bulk of your business logic into the model layer. This is associated quite a bit with MVC, of course. So I have MVC in these huge letters right here. It's kind of this monster that everyone talks about. There's this big brick building and the brick wall in the background. It's just this kind of massive thing, MVC. Oh, you must know what you're talking about. So MVC, is Symfony an MVC framework? This is kind of a gotcha question. No. I mean, you can do MVC using Symfony as a framework, but Symfony was not built for the purpose of implementing MVC. Symfony was built for the purpose of responding to HTTP requests with HTTP responses. This is why Symfony was built. So more than an MVC framework, Symfony is an HTTP framework. So if we think of it in that way, over here we have HTTP land. We have a request that comes in from HTTP land into application land here on the right. And this red stripe in between, this is one of the mapping layers that I identify in my application when I'm deciding where something might go. That mapping layer in this case is the controller. So when we talk about thin controllers, that's kind of It's not very specific, right? Okay, my controller should be thin. So in order to flesh that out some, I think of a controller as a mapping layer. It maps from the language of HTTP into the language of whatever into the language of your application. So there's a separation here. Anything that has any knowledge of HTTP is on one side, and then the solution to the problem that your application is solving is on the right side, and it uses its own lexicon of words. It uses its own objects that have nothing to do with HTTP requests and responses. So the controller is thin because it's a mapping layer between the HTTP land and application land. Okay, controller is a mapping layer. Does it make sense so far? When I say controller is a mapping layer, controllers are thin. They just map from one language to the other language. Okay, so coming back to the idea of thin controller, fat model, what about the model? I see things this way. There's another stripe down the middle of the screen here, right? We have application land, and then we have persistence land on the right side. And that thin blue stripe in the middle is another mapping layer, and that is the model. So this term MVC, I've been doing a lot of programming in iOS lately using Swift. If anyone has used Swift, it's actually pretty cool. It's a lot like HHVM. But Swift and working this is my first time working in more of a kind of a GUI application environment. And MVC makes a lot more sense there. For me, in my mind, working with in the world of HTTP, which is a stateless protocol, right? We need to have a persistence layer on the back end. And so one of the main problems we need to solve is how to turn a request into a response, right? At the very tip of the iceberg. And then below that, how to create this feeling of state. And we do that with persistence in the back here. And the model is what maps between the land of persistence to the land of your own application. So put it all together, and you have something that looks like this. HTTP land maps through the controller to application land, and application land maps through the model to persistence land. So thin controller, fat model makes, well, I have more layers than that, the way I design my applications. So it's not quite thin controller, fat model, because we have this application layer in there too. And who lives in that application layer? It's the services, right? So you have this library of classes that are responsible for solving the problem of your application, the problem that your application is trying to solve. And this is what lives in the application layer. So that's not coupled to Symfony framework. It's coupled to whatever you would like it to be coupled to, right? We give you that flexibility. You work between these two mapping layers, if on the right side on the persistence land, that would be something like Doctrine to help you work that. And then on the left side with HTTP land, that would be something like Symfony to help you work with that. In your own application, you'll probably be able to identify other mapping layers that say, oh, okay, yeah, so I'm interfacing with this particular land on that side. So in my work as a consultant, I see a lot of applications where there's a lot of code crammed into the controller, right? Because that's where you start, and then you just code it all out there. And then maybe you think you'll come around and clean it up later, but not everybody does. So some of the, when I say move your code into the service layer, out of the controller into the service layer, a lot of people go to this concept of a manager. And I have a bit of a problem with this. Let me take a step back with another perspective on controllers that you should write down, is that a controller can know what to do, but it doesn't know how to do it. So It can look at the request that's coming in and say, okay, that request is to do this. Doesn't know how to actually do that, though. It just delegates to the service layer to actually do that, right? Now, I've spent some time as a manager myself, as a project manager, architect type role, and it took me some time to adjust to this role of manager. And what I took away from this experience is that the best managers don't actually do anything, right? They have other people do it, and this was difficult for me because I'm used to, sitting down at my computer and actually doing something to fix a problem or to write out some code. When you're a manager, though, if you do that, it's actually detrimental to the project, right? You should be spending your time doing something else and have someone else should be solving this problem, while you should then go on to the next problem and figure out who should solve that problem. So managers don't actually do anything. Managers might know, so similar to the controller, similar to what I just said about controllers knowing what to do, but not exactly how to do it. So if you take that code, that big chunk of 200-line method in your controller and say, oh, okay, yeah, I should move that to the service layer. So you say, this is, I'm going to take this method in my widget action, in my widget controller, and copy it into the widget manager. And then my controller is going to call the widget manager, and then the code lives in the service layer. Problem solved, right? Not quite, because this manager thing, you can have a manager if your code warrants it, right? But you shouldn't jump to creating these manager objects, because your controller is already responsible for knowing what to do but not how to do it, right? So instead of having your controller delegate to a manager who then delegates to whatever's actually going to do it, you can just have your controller delegate directly to the folks that need to know how to do it. If you have an application which has more complexity, you might have a need for that manager. So I don't want to say don't use managers, but I'm just saying have a clear idea of what the role of a manager is, and the role of the manager is not to do anything. Got it? All right. Another thing that I use a lot in my applications are events. And an event for me is when this happens, that happens. So if you can describe something in your application as whenever this happens, that happens, then there should be an event there. Whenever this happens, that should be the dispatching of an event. Then that happens, that should be an event listener. Whenever this happens, that happens. So the this that happens is something that a request might come in saying, hey, I want this to happen. The controller sees that, and the controller delegates it to someone else to do that. In the process of the service layer handling that, an event is fired saying, hey, this just happened. And then the whenever this happens, that happens kicks in. So I have buckets up here. Does anyone know why I might have buckets when I talk about events? When you have an event, you can break apart all these things that happen in your application into tiny little classes, into tiny little event listeners. Whenever, I'll have some examples in a moment. So first off, listening. We're going to listen to an event. In this case, whenever a user is created, we're going to add an entry to the activity stream. So something like Facebook, you have a stream coming down of things that have been happening in your network, right? So we listen here to the user created event, and on that event, I'll get the user from the event, create an activity object, and then persist it into the persistence layer. Whenever this happens, that happens. Whenever a user is created, an entry goes into the activity feed. What's this one? Whenever a user changes that their username. If you're in a denormalized persistence environment, then you're going to need to update all those denormalized usernames. So something like Mongo, if this is specific to a denormalized case. Or whenever a user follows another user, we need to increment that user's number of followers and increment the other user's number of followees. So this concept of whenever this happens, that happens, helps me to break apart an application which otherwise might be really tangled up together into small buckets. So this, the first one that I showed you, the activity listener, that one, whenever a user is created, an activity, an entry should go into the activity feed. You can imagine there would be a lot of other methods on that listener for whenever someone follows someone, then you'd have another entry go into the activity feed. So these are some examples of listening to events. But where do these events get fired? Where are they dispatched from? How do you dispatch one of these custom application events? Well, you're going to want to create special event classes for each of your model objects around which events happen around. So in the examples I was just showing you, they're all about things having to do with users. So you would have a user event class, which takes the document manager in this case. I should say I do a lot of work using MongoDB as a database, so these slides assume you're using the ODM, which is why you see document manager, the DM. So you'd provide the document manager into that event and the user object that's in question, and then dispatch it using this constant for a user was just created, and you dispatch that event. So you have one event class which you can use for any sort of event that happens around users. When a user is created or when a user is updated, that first line is the same. You create a user event and then pass it to the dispatcher with a different event name. And then that would eventually get to the listeners that we saw earlier. And then in the case where you might have a more complex event, if one user follows another user, then you'd want to have the user who did the following and the user who was followed as two arguments in that user event. And you'd dispatch that using the follow constant. So the important question that's left unanswered is where in my code, do these events actually get dispatched from? Like where does this code live? So that's kind of a tricky one, right? Does that live inside of the controller? Does it live inside of the service layer? Does it live somewhere else? I put that code in a listener, actually, this Preflush. So Doctrine, if you're familiar with Doctrine, has this concept of flushing changes to the objects in memory down to the persistence layer. And there's an event. Doctrine has its own event manager, so events get fired out of Doctrine. And the one that I look at for firing off my application events is Preflush. So I'll watch Preflush anytime flush is called, this event is fired, and I can look at every single object in my identity map, every object in memory that Doctrine is watching, and look at any changes that have happened to that object from the time it was loaded to the time that it's being flushed now. And from those changes, I can infer whatever events I need to fire. I can infer that, okay, a user just followed another user. A user was created. A user object was updated. All the examples that I just showed can all be identified inside of the unit of work Preflush event. And that code looks something like this. We have the Preflush listening method here. We get the object manager in the unit of work, and then iterate over the identity map. And the identity map is an array of all of the objects Doctrine knows about. So the first The key for that array is a string, which is the class name of that particular object in Doctrine, and then an array of the objects of that class that it's watching. So you can see I loop over, and if this is a user, then I'll loop over each of those documents and process that flush. So this method in here would have some logic to look at what the current values of that object are, and then it would ask the unit of work for the values that it came out of the database with, and compare the two, and say, oh, the user was updated, I'll fire the updated event. Or say, oh, there's nothing in the database, this user was created, I'll fire that user create event. Or if we see that that user is now inserting the follow, then we'd fire that follow event. And then moving on, the same thing to with a widget class there. So decoupling this process, all those buckets that I had at the top, that's decoupling all of this logic in your application to single-purpose event listeners. So we've got mapping layers so far, and then events on top of that. Now I want to talk a little bit more about the model. Like I said, I use Mongo quite a bit. I just prefer the flexibility that it provides. When we're talking about the model as a mapping layer between the application land and persistence land, and it therefore being thin, I'm going to flesh that out some more for you now and give you a little bit of personality around this concept. Specifically, I think you should start thinking about your model as something of a princess, right? Your princess is going to get her own wing of the palace. So for me, that means we have this namespace here, Kris \model, or whatever your application is, right? So we take all those model classes, take them out of the bundle, and put them into their own namespace. Make sure that they don't have dependencies on anything else, right? So these are the persistent objects that you're going to use to solve the problem that your application is solving, right? So all of those live outside of any bundle. They can live inside of a model namespace, and using this configuration, you're then able to access those model classes in Doctrine using just the model alias :user, and you'll be able to get that user class. So the princess also doesn't do any work, right? Let's take a look at a method on the princess user class. So when we set the username on user, there's something else that needs to happen here, right? We set the username, but we also need to have a canonical username that's set so that we have a case-insensitive version of it to enforce uniqueness. So here's one way that you could accomplish that. You have the canonicalizer, which canonicalizes this username into the username canonical property. You can move a little closer to dependency injection by having a second argument on that class, which is the canonicalizer. Still, the user class is doing too much here. The user class in your model shouldn't know that this needs to happen. It should be unaware of all the work that's being done around it. So this relates back to what I was just talking about with events. Whenever the username is set, the user class doesn't do anything about canonicalizing it. There's going to be a listener that comes back later and sees that the username was changed, and then uses the canonicalizer to set that canonical username. So this, a lot of times when people teach object-oriented programming, they might take an example from the real world, like a cabinet, and say the cabinet is an object, and then on that cabinet, there's an open method, right, for the cabinet, for opening the cabinet. My main point here is that cabinets don't open themselves. There's something that's doing the opening. For me, the cabinet is a noun. That cabinet is the persistent object. And then the opener, the object that is doing the opening, is a verb, and that lives in the service layer. I think this is one of the last sections, contextual configuration. This is another, this is just something, a term that I've coined to help you save a future headache. If you look at this code here, this should look familiar to everyone. This is how you define a service class in config.yaml or widget.yaml. And if you kind of unpack this, there's a lot of mental hoops that you're going to need to jump through in order to first create this and subsequently maintain this. You can see up here, we're creating this in widget.yaml, right, which is then imported somewhere in the chain up into config.yaml. So I have this service. I have to figure out what YAML file is the proper one to put it in, right? The widget twiddler service would not fit in the user.yaml, right? Because it doesn't have anything to do with any classes around, any services around users. So I have to look at the YAML files that are there already, decide if it fits into any of those, maybe not. Maybe it kind of fits into that one, but okay, I guess I should just create another YAML file for this one. Now I have a YAML file with just one service in it, and I have to import it somewhere. I have to make sure that I get the class name perfectly right, otherwise it's not going to work if there's a typo there. And then down here I have the arguments, and this is detached from the class itself. So if in the future, when I'm continuing work on my Twiddler class, if I want to change the arguments or change its dependencies, I'm going to have to make a mental note, kind of stop, get out of my workflow, and come over here into the YAML file and update the arguments here. So the point I'm trying to make is this is not very efficient. I prefer to go the route of annotations using the JMSDI extra bundle. And this is the exact same configuration that I showed you before. I don't even have to think about what YAML file it goes in because there are no configuration files. The configuration is in the context of my code. So I don't have to leave my workflow. I'm looking at the PHP class that I'm working on. I add an annotation to the top to define the service, exact same service definition as before. And then I add an annotation telling it that it needs to pay attention to the arguments here and inject those. So the DI extra bundle will look at the name of the variable that you use, and it'll try to find a service with that name and then inject it there. So there's no service that comes in the Symfony core called dispatcher. It's called event_dispatcher. So this wouldn't work right out of the box. But what I do to fix that is create a few aliases for the services that I use more often. So if I ever inject the container, I could just have that variable named container DM instead of this long string, doctrine, dispatcher, security context. So these aliases will make it easier for me to use that auto-wiring feature of the DI extra bundle. And if we look back at this one here, the logger is an optional dependency. And the DI extra bundle is smart enough to know that since I have it marked as optional here with a default value of null, that the dependency is also optional. And it configures the container accordingly. I want to draw your attention to Requiredjs. This is it's typically referred to as a loader inside of the JavaScript world. I look at it more as a dependency injection solution. It's very similar to what we we do in PHP with the Symfony service container. You can require, you can define a module here and require the user view and then the user model. And these will both be injected into this closure, and then you can do what you need to do. Here's some twig to serialize that user object into JSON and populate this user model object with the data from the database, and then provide the view and element from your template as well. So Requiredjs is the best implementation of dependency injection that I've seen in JavaScript. And if you do work in JavaScript, I would definitely check this out. It's a real pleasure to work with. One thing that you saw on that last slide was the twig to serialize a user into a JSON string. If you look more closely here, this is using the JMS serializer bundle, another JMS bundle. And the way you work with that is on your model classes defining. I always start with an exclusion policy of all. So you put this annotation up at the top, and nothing will be serialized. I prefer to explicitly say the fields that I want to have included in the serialized version of my objects. So 5 more things. I think a question people come up with or have a hard time answering is when to create a new bundle. During the process of building out an app, you might come to a new project and have to decide, does this belong in a new bundle, or should I just cram it into a bundle that I have already? These are unnecessary hoops that we're jumping through in my mind, like I was talking about before with the YAML files. They take you out of your workflow, take you away from coding the solution to this problem that you're being paid to solve. So I want to help provide some guidance here. It's not, I don't want to overemphasize it though. It's not something that's going to make or break your application if you move something into a new bundle or not. First of all, anything reusable. If you think that this is a common problem that other people have and you might eventually be able to move it into the open source world, of course that's a good place to start. If you think that, then you should probably also go check to see if someone else has already solved that problem, and then you can use that and fix any issues or enhance it in any way that you need for your particular use case. If you're on a team and you've been tasked with a new feature, I would always, when I'm on a team, take that new feature and just create a new bundle for myself to work in so that I can have my own section of the test suite and have a nice solid package that I can then deliver and say, okay, it's done. That package can very easily then be merged into a main bundle or a master bundle or whatever your application uses as its central bundle, or not, or it could be kept on its own. But this is more of a workflow issue, a piece of workflow logic. If this is a project that I've been tasked with, and I'm on a larger team, then I might put that in its own bundle. If there's lots of classes relating to one feature, so if this particular feature interacts with a lot of different parts of Symfony, you might just have that, it might deserve its own bundle. Integration with a third party. Another key that I look for is something like this, where you have these long template references. So we're inside of main bundle, and then I have an account folder, and then inside of the account folder I have a widget controller, and then I have a sidebar template inside of that. So this slash right here is a flag for me. I would much rather see this. So that's kind of working from the complexity you might see as you're drilling down into your solution. You might find that we've gone down enough levels of complexity that I should just take this and put it in its own bundle. On the point of access control, I don't know if anyone is familiar with the security component. Symfony has an ACL, which is a very nice feature. But so ACL is for arbitrary permissions. If you want to be able to say, this user has access to do this, that, and the other thing, and then this user can do these two things. If you are using an interface like this on your admin side to determine who has access to what, these are arbitrary permissions, and this is a good use for the Symfony ACL. This is not very common. I don't see a lot of applications that actually require arbitrary permissions like this. A lot of times permissions are based on business logic. So if I'm the user that created this particular object, then therefore I should have access to it. That's logic, right? It's not arbitrary. So Symfony provides another mechanism for access logic called a voter. And if you search online, you can find details for how to create a security voter. But it's a lot easier than having to maintain the ACL every time an object is created, to insert another ACE for that object so that this user can then have access to it, and then what happens if that user is deleted and whatnot. So this is, as you can see here, this is the logic that determines who can access a widget. If the current user is the user that created the widget, then they get access. So this is what the inside of a voter looks like. And once you have this in place, you can use yet another JMS bundle, the security extra bundle, to secure your actions like so. So if you have an edit action, you want to be sure that whoever is editing it has the owner permission. Then this would tie back to that voter that I just showed you, so that whenever the owner permission is requested, it's going to, behind the scenes, check to make sure that the current user is the owner of that widget using the logic in the voter. Similarly, in your template, you can ask if the current user is the owner of this particular object, and then add something to your template there. Two more quick rants. No query builders outside of repositories. This is query builders need to have knowledge of how an object is persisted, and this knowledge of how, I'll come back to what I said earlier. How something is done should be contained. So the knowledge of how an object is persisted should be contained. If you have query builders in your controllers or spread out across your services, that knowledge of how your objects are persisted is spread out everywhere. We want to keep that contained inside of your repository classes. And with it contained, you have the added benefit of being able to quickly audit your code and see what indexes are necessary for the queries that your application is running. So in this case, with the widget repository, we could find widgets by user and then update denormalized usernames. So the one index that we should have here is on the user ID column or field. It's used in both of those, and we can look at at one class to see all of the queries that we're running against this collection and be sure that we have the indexes that we need in place. Eager ID creation. This is another tidbit specific to Mongo. You can actually create new Mongo ID objects in your PHP code. You don't have to send the object to the database and get an ID back from it. Mongo is built in such a way that you can create those IDs in your code when you create the object. So I always have this in my constructors for any objects that are going to go into Mongo. A few other things too that created at timestamp. There's no need to do this in a listener. We can just create that in the constructor, and it's important to initialize those reference many or embed minis as a collection object instead of an array. So that would be in the constructor there. And don't forget about your clone constructor. If your application is going to be cloning these persistent objects, you want to be sure to do the same things there. There are two ways to create new objects inside of PHP, or two primary ways. One using the new keyword and one using the clone keyword. So these are kind of brother and sister, and you should think of them like such. And when you use new, it goes to __ construct. When you use clone, it goes to __ clone here. So if you're cloning something, then you're going to want to make sure it has its own ID. It has its own created at time instead of the one from the original object. And then you're also going to want to create a new copy of this array collection so that Doctrine doesn't get confused and think that this array collection belongs to the previous object. So in those classes where you're going to be cloning, I would have a new constructor, and then right below it a clone constructor, so you can check to be sure there's some parity there and that they're both working on the same fields. And now I think this one is my last one, really. Only flush from the controller. You might be tempted, coming from an active record background, to, instead of call save at various points throughout your application, to call flush at various points throughout your application. That's really an anti-pattern. Doctrine is built in such a way that you only need to call flush once at the very end, and it should be your controller that's doing that, or whatever is standing in that role of the controller. So the controller, like I was saying earlier, is mapping from HTTP into your application. On the command line, you have these command classes, and they are mapping from the command line into the language of your application. And so in that case, you would want to have the flush call be inside of the command object. It might look like this. You call flush at the end of your action there. All right. I'm done rambling on. Does anybody have any questions? All right, here with the body shirt.
Hi. By the sounds of it, then, you really don't have too much problems having lots of bundles in your application.
What's the question?
Do you have any problems having lots and lots of bundles, each doing their own distinctive things?
No.
But even doing just little things?
No, you might have misunderstood me. I'm not advocating for a lot of bundles. I think bundles should be a kind of a fluid thing. For those cases when I said you can create a bundle for a new feature, a bundle you should be able to easily merge it into an existing bundle. So for the course of when you're first starting on a certain feature, you might isolate that in a bundle, but that doesn't mean it has to stay there.
Right.
Then you can merge it in with the rest of the work.
Okay.
Hi, that was really interesting, thank you. Thinking about thin controllers, I often find that a lot of my controller method is taken up with getting the different parameters that I'm then going to need to pass the template when I render it. Where would you put that?
Getting parameters from the request?
And from anywhere, really. So, I'll say to some logic, go off and manipulate this object, and then go off and manipulate that object. And all of the logic is somewhere else. And then once all that stuff has happened, I then need to tell the user about it through the view. And so I've got to in order to tell them that, I've got to get a bit from the object that I manipulated here, a bit from that other object, and a bit from over there. And it's that kind of get this bit, that bit, and that bit, and then put them together into an array that ends up becoming quite a lot of logic in the controller.
Yeah, I mean, there's a concept of a view model that you might want to look at. So there's the objects that that map to how information is being persisted, but there might, in your case, be another set of objects that would be more appropriate for how information is presented when you send it into the view. So you could have one object that decorates many of your persisted objects that then gets passed to the view. Is that making sense? So
Yeah, that does, thank you.
So that instead of having a big array of stuff that you don't need all of that stuff, you need one thing from each of these 6 objects that map to how that information is persisted. Instead, you might conceal that inside of a view model that only provides accessors for the specific things that your view needs.
Cool, thank you.
Thanks for that. There's a few things I'll take from that. The clone is pretty cool. The question I've got might be a bit of an anti-question. The annotations that you stick into your services, basically what you're doing is you're really tightly coupling the application code to the framework. Okay, and I appreciate this is how to build Symfony applications, but do you not worry about that tight coupling?
No, I don't. In the end, an annotation is a comment, right? So the class can still be used outside of the framework.
Right, so a new framework would just ignore the annotation and march on.
Yeah. For me, I mean, there's this balance when I'm coding is what's going to make my job easier now and what's going to make my job easier in the future. And the stuff in the future, you got to look at it all with a grain of salt, right? I don't know if I'm actually going to need to move away from Symfony, the premature optimization, like there's all kinds of words that you could put after premature, like premature bundleization, premature whatever. But I think that for me, the most important consideration is just my own sanity now, and to be able to do things quickly and without a lot of friction.
Thanks for the talk, very good. I had the question around the models. You were saying that, as you have the picture on here, that they're princesses. And, the work they do or not do, I find it kind of, I find leaning from one to another way. And then sometimes I have trying to put more logic in there to avoid them becoming anemic models. And then you kind of look at it that you don't want to do at all the work, and you mostly have accessors and getters. Is that true? And how you view that anemic model problem that everybody's talking about?
I'm not sure I totally got your question, but I'll say more about it. With that cabinet open example that I had before, there's like in that case, I would have a method on the model called open, which would change the state to reflect that the cabinet is now open. But I would be just aware of who's calling that method as well, and anything bound up in the act of opening it would belong there.
So basically, the state transition in the model would still be there. All the methods and things to change the state or whatever is still in the model, but what's doing it is just outside. Okay, I'm kind of misunderstood. Thanks.
Hi, my question is also about tight coupling, not regarding the annotations, but regarding the persistence, because on your example, specifically on the ones about the events, you tend to have the document manager as a dependency of the event itself, wouldn't you rather have it as a dependency of the listener, for example? Because you might have listeners that want to persist, you might have listeners that want to persist using another technology, etc., etc.
Yeah, I mean, it could go either way. I see what you're saying, that document manager could be injected into the listener instead. And I think that I started that way, but I just found myself using it so much that I put it into the events. And I think one of the other things that I ended up doing is having on that event class, having a special method to ask if a certain field has changed on that object, and just having it live inside of the event with the document manager, which comes out of the unit of work listener. It's just,
thank you.
Made my job easier. Any other questions?
Going back to what you said about earlier on about abstracting the model away from your bundles and having that in its own separate namespace, do you do that with anything else? And do you just stick it all within the source directory alongside your bundles? And also, it's two-part. Do you have any issues with having like an app or a main bundle? And I often struggle with finding the feature that defines that this needs to be moved away. And how do you avoid that in that sort of scenario?
Yeah, the only thing I move into outside of bundles is the model, are those persistent objects. Going beyond that creates more problems than it solves in my experience. The other way to think of it is, I was just up in the dependency trap talk, and the images that he had of the concentric circles make a lot of sense, with the model being in the middle, and then the model never interfacing directly with Symfony, which would be one of the larger circles on the outside, but interfacing with the service layer here. So the service layer is interfacing directly with Symfony, but not the model. So we can go ahead and take the model outside of Symfony and leave the rest of it inside of Symfony, because the two of them need to work together anyways.
And do you see any problem with having like a main bundle in your thing? Because I've kind of always, when I'm doing it, I consider it an anti-pattern, but I don't really have a better idea than doing that.
I can relieve everybody of any guilt that you have for having a main bundle. It's okay. Any other questions?
Anyone on the other side of the room want to ask a question? Hmm? Well, can I just ask this gentleman first, who's asking his first one? Oh, and I'll come round to you.
Hi. Yeah, it's a question about flushing. I think maybe you might have ended up coming to flushing with a controller. Obviously, it kind of breaks all manner of abstractions, because you're calling services which may or may not use the doctrine persistence layer. Is that just because it's easier, because these services might do kind of n number of things, and you just want to flush once, and it's at the top of the execution tree? So it's a wee bit of ugliness, you're just going to stick the flush in there.
Yeah, the services all work with objects in memory.
Yeah.
Right? They don't need to worry about putting changes back into the database. They might get objects from something called a repository. That doesn't mean they know how that they were persisted or whatever. That's just a class that they can get objects from. So all of the services should manipulate the objects in memory. It makes their job a lot easier. And then they don't have to worry about flushing, or you might need to say, okay, do this and then flush. Like anytime you have a Boolean parameter at the end of a method, that's another red flag that says, like, if there's a parameter called and flush true, like, just get rid of that. I mean, in that particular case, get rid of it and never flush. And you can flush later. In other cases, you might want to take that and just split it into two different methods. Is that?
Yeah. Thanks.
Yeah.
Thanks. Just to follow up from the question at the front about folder structure. So am I right, you put your business logic in your bundles,
Yes.
Where under there, what are your subfolders?
Okay, well, yeah, so there's not a folder called services, right? You should create namespaces that are appropriate for the services that you're creating. Creating a namespace called services means nothing to me, right? If I'm looking at that, I'm not going to know what's in there. So I had some, I might have an event listener folder, and then beyond that, it just depends on the problems that we're solving. If I'm building some kind of an engine around comparing two objects, and then showing, coming up with some comparison of two objects. If that's part of the problem my business is solving, then I might have a compare namespace, and inside of that have my own classes that solve the problem of comparing two objects.
So that would just be directly under your bundle name. So you might have quite a lot of subfolders directly under your widget bundle or whatever. Mm-hmm. Okay. So mixing in folder names that relate to your logic and folder names that are the sort of Symfony specific ones. Mm-hmm. Okay.
Yeah.
Cool. Thank you.
So back to flushing. Do you not have any sort of fears in exception-based situation that you might miss something, some really important persistence at some point in your controller if it was, say, throwing a Symfony-based exception such as resource not found or 404 exception, that you might have chained a lot of logic, done something important, and then it's never persisted to the database?
I'm not sure I understand.
If your flush is only in the controller and you've got exceptions going on that could not be handled within that controller, then your persistence might get missed, rather than saying, I know something really important has happened, I will flush it at this point, and I know it's definitely saved.
And if what's happening inside of one action is that complex, then you're going to want to, build to handle all of those error cases. So if there's an exception that comes up at some point, then if it's the right exception, if you know where that exception came from, then you would want to flush and then throw the exception. I mean, it's hard to say, but I've never had that issue. Any other questions?
Time for just the odd one or two more.
I can't hear you. Oh, finally, yeah. Finally, what was that, 5.5 we have finally now? Okay. Well, thank you everyone for coming. I'll be around if you want to talk more.